Okay, so in this video, we're going to look at finding the equations of inverse functions again, but this time we're going to move into a slightly more advanced type of equation. So in the last video, we took a look at linear equations, and we also looked at very simple, very basic polynomial equations. And those are really the two types of functions that we focused on in our class so far, linear equations and polynomial equations, which I suppose linear is kind of like a type of polynomial, but also, quadratic and cubic and so on. Of course, I did say in the last video that we'll never ask you to find the equation of an inverse unless the inverse is also a function. And we know from our first video that because quadratic graphs are shaped like parabolas, parabolas will fail the horizontal line test. So quadratics don't have inverses, or at least their inverses are not functions. All right. So in the last video, we looked at linear and we looked at very simple basic cubic. And that takes care of really what we're going to do as far as polynomials. In this video, we're going to look at a new type of function, a function that's called a radical function. And specifically, we're going to look at functions where the radical is a square root. So square root functions, right? So only one learning objective again in this video. And it's simply to be able to find the equation of an inverse function when you're working with a radical. And specifically, like I said, the radicals that we'll look at in this video are square roots. Okay, so that's my abbreviation for square roots, but that's really what we're looking at. Now, the one thing that I want to emphasize before we even get started, in the last video, we looked at these 4 steps for finding an inverse function. Notice that this is not the steps for finding the inverse of a linear function or the inverse of a polynomial function. These are the steps for finding an inverse function. These steps do not ever change. It's always the same 4 steps. But what we'll see as we go through the semester and we look at different types of functions is step 3 is going to change depending on the kind of function you're working with. When I had a linear function, I just had to add and divide and I was done. When we looked at the cubic one, I also had to take a cubed root. Now, as we look at radical ones, we'll have to do something to make the radical go away. So with that said, actually, you know what? I'm going to keep those steps handy. So we can look at those steps as we go through this video. And you may even want to jot those steps down again in this particular set of notes. So if you need to pause the video for a second and write those down, that might not be a bad idea. But here's our first example. Again, the directions would say something to the effect of find the equation of the inverse function or something like that. And then they would give you some function. I used f a lot in the last video. I'm going to switch to g this time, just because why not? All right, so here's function g. Function g is the square root of x plus 17. Okay, so we're going to start with a very basic one. We'll do a second example that's a little bit more complicated. We're going to start with a very, very basic one. All right, so we know that the first thing we want to do is think of the f as being a y. So whether you actually write it or whether you just mentally in your head think about it, we want to remember that the g of x is the same as a y. So this is really what we're dealing with. The square root of x plus 17 is equal to y. Then the way that we actually create the inverse is we switch the x's and the y's. So this y is going to be replaced by the x. And this x is going to be replaced by the y. Everything else in the equation stays the same. So here's my equal sign. There's my square root sign. There's my plus sign. And there's my 17. So as we said in the last video, technically at this point, this is an equation of the inverse. But it's not the equation in the standard form that we like to write it. It certainly is not in function form. So the next thing I want to do is get the y by itself. And this is the part, as I said just a minute ago, that will vary depending on the type of equation that you're working with. You might remember from last semester, when we're solving a radical equation, the general idea for solving a radical equation is first you get the radical by itself. So in this case, to get the radical by itself, I got to get rid of this 17. So I'm going to subtract 17. After you subtract that 17 from both sides, now in this problem, that's all you have to do in the radical is by itself. So we need to get rid of the radical. And what cancels out radicals? Squares cancel out square roots. If it was a cubed root, I would use a cube. If it was a fourth root, I would use a fourth power. But this is a square root. So to cancel out a square root, I'm going to use a square. So I have to square both sides. And again, like I said in the last video, remember that when you're working with exponents, technically you're squaring the whole side. And because that side has a plus sign, or in this case, a minus sign, exponents cannot distribute. So I can't distribute this. So we'll talk in just a second about, so what do I do with that? We'll talk about that in just a second, but I can't distribute it. One other thing that students sometimes do, and I hesitate to say this because it's a common mistake that students make, and I'm afraid that if I say it, that's just going to reinforce the idea that you should do this. But this is something that you don't do. This is something to watch out for. When we're solving square root equations, when we're solving radical equations, squaring does not introduce any kind of plus or minus sign. What introduces a plus or minus sign is if you start with a square and then you take its square root. So we're doing it the other way around. We started with a square root and then we're squaring. Sometimes students like to introduce a plus or minus sign here, but that would be inappropriate. Okay, and it's mathematically incorrect, not just inappropriate. All right, so what have I got? This side, the square and the square root cancel. On this side, I have x minus 17, and it's being squared. But as I said just a minute ago, that square does not distribute. So what do I do with it? Well, for this, we're going to rewrite it using the definition of a square. The definition of a square is it's the thing being squared times itself. The thing being squared times itself. And so now I just need to simplify this to put it into standard form. And to put it into standard form, what I will do, just like we did last semester, is use a double distribute technique. So I'm going to distribute that first thing into the parentheses. There's my first distribute. So I get this thing times an x. And then I get this thing times a negative 17. Okay. Now, one of the things you might remember that I talked about last semester is the reason I can make this a negative 17 is because I treat this not as a minus 17, but as being plus a negative. So that plus sign stays in the middle. And then the negative 17 is what I'm multiplying by. Okay. And now I go back and I distribute again. So there's my double distribute. I distribute again. And once again, I'm going to think of this the same way as being plus a negative 17. So when I distribute, I'm going to get x times x. Well, that's x squared. And then x times negative 17, that's going to be a negative 17x. And that's it for the first one. And then I've got this plus sign. Negative 17 times x, that's negative 17x. And then negative 17 times negative 17. And so that one, well, that one, I'll be honest, I'm not sure. Let me grab my calculator. Negative 17 times negative 17. That is 289. Now, I forgot to mention up here, all this is still equal to y, right? That y hasn't gone away. So when I combine together my like terms, these two things combine together. So I've got an x squared minus 17 and 17 combined to give me a 34. And 289. And now I'm in standard form. And so once I get it in standard form, then we said in the last video, we're going to replace the y with function notation, although this time it's not an f, this time it's a g. So I'm going to turn the y into a g with a -1 exponent, and then write my equation out in standard form. And so this becomes the basic idea of solving a radical equation. Okay. Now, one quick side comment on this before we move on to the next example. When I did the double distribute technique here, I want to remind you of there is other methods. Like, for example, if you liked using FOIL, you can still use FOIL, that's fine. But the other thing is, because this is coming from a perfect square binomial, it's a binomial that's being squared. We did learn last semester a shortcut for doing these types of problems. I'm not going to review that in this video, but if you remember how to use that shortcut, or if you want to go back and watch the video from last semester, I'll put a link to it in the comments below. You certainly can do that. And you can use that shortcut if you want to. All right, so there is our first example. Let's do one more example that has a little bit more stuff going on, and we'll call it a day. So here's example number 2. Example number 2. I'm going to go with a different letter this time. Let's call it h of x. And let's suppose h of x is the square root of a 3x plus 4. Square root of a 3x plus 4. All right, so what do I need to do? Well, actually, at this point, you've seen this set of steps often enough. Why don't you see if you can pause the video and give this a try on your own? If you get stuck along the way, you can always start the video again. Or maybe just do the first step and then resume the video and see my first step. And then pause it and do the second step and then resume the video to watch my second step. And just keep going until we get all the way down. But why don't you give this problem a try real quick? All right, so hopefully you've tried this. Hopefully the first thing you did, whether you wrote it or whether you just thought about it, is the fact that this function notation h of x is the same as a y. And once you realize that that's the same as a y, then it makes it possible to do step 2, where I take my x's and I take my y's and I switch them. All right, now we're ready for step 3, which is get the y by itself, solve for y. Now this time, the radical is already by itself. There's no extra stuff before or after the radical that I need to get rid of. So I can jump straight into, let's square both sides. Now, on the left-hand side, because there's no plus or minus sign, all I need to do is just square x. So x times x equals x squared. Boom, that's pretty straightforward. On the right-hand side, remember the purpose of the square is to cancel out the radical. So when the square and the radical bump into each other, they cancel each other out. They completely eradicate each other. They're gone, which means the 3y plus 4 is left all by itself. There's nothing to impact that anymore. There's no square root sign because it was canceled by the square. There's also no square because it was canceled by the square root sign. So I'm just left with 3y plus 4. Now I need to get that by itself. So this is a little bit more like our linear equation type problem. I can subtract 4 from both sides. No like terms here, so I just get an x squared minus 4 equal 3y. And then I can divide both sides by 3. And again, remember, technically, I'm dividing this whole side by 3, but division distributes. So it becomes an x squared over 3 and a 4 over 3 because division distributes. Okay, so that's what happens because division distributes. With the last problem, exponents did not distribute. So I couldn't do that. I had to go through this whole process of foiling. But division distributes. So that makes our life easy. Here, my number in front of x squared is a sneaky ninja 1. So I've got a 1 divided by 3. Well, that's a third. And then I've got a 4 divided by 3. And I'm just going to leave that written as a fraction, 4/3. You could make it a mixed number, 1 1/3. You could turn it into a decimal, 1.3 repeating. I'm just going to leave it as an improper fraction. And then that's equal to, well, these 3's will cancel, so that's equal to y. And now I've got it in simplified standard form. I've got it, the y by itself. So I'm ready for my last step, step 4, turn the y back into function notation. Remember, this time we're working with function h. So I'm going to turn the y into an inverse of h, and then write out the rest of my equation. And at this point, I'm done with that problem. Okay, so this is the general idea for finding the inverse of a radical function. Like I said a minute ago, I will put down in the description for this video a link back to the videos from last semester that reviews solving radical equation and also reviews working with these types of expressions and simplifying them. So if you want to watch those videos, you'll find those links below, and you can watch those if you want. So that's it for this one. Thanks for watching. Have a good one.